Okay, so let's talk about the second problem, maximum gain of this Google Kickstart round D 2022. Like if you haven't subscribed to our channel yet, I would strongly recommend you to do that because we are going to update all the important contest solutions and also the conceptual educational videos also we are going to upload that. Okay, so let's begin with the second problem of this Google Kickstart maximum gain. Okay, so first of all, I would recommend you to look over the constraints. Like n is maximum 6,000 and m is 6,000 and k is 3,000. I will ask you to remember this one because this constraints is going to help us a lot while we are framing out the solutions. Okay, so let's begin. Charles is participating in an event of crowdsourced task and is most enthusiastic to gain maximum points from there. There are two crowdsourced tasks, audio and validation task, an image labeler task. Each task consists of a list of questions. Charles is given two arrays A and B representing the two tasks. Each element of an array indicates the number of points that Charles will gain by answering the corresponding question. Okay, so basically we will be having two arrays, array A and the array B. It will denote some of the elements. Let us say we are going to follow zero based indexing and it goes up to an minus 1. So both the arrays are of same size, I guess. Let me just check it out. Yeah, n and m. Okay. No, both the arrays are not of same size. Yeah, I will look out the solution, that will be more clear. Yeah, both the arrays are not of same size. Okay, so there will be another array b0, b1 and it goes up to bm minus 1. So there are two tasks, task A and task B, and answering the ith question of task A will give you AI points, will give you AI points, and answering the ith question of task B will give you BI points. Okay, so yeah, so let's look out for the another one. Charles is allowed to answer quick questions in total from both the tasks. Like Charles is going to answer a total amount of k questions, and this k questions we are going to choose from either task A or task B. Like suppose I amount of tasks are chosen from task A, then k minus I amounts of tasks must be chosen from, like k minus I amount of questions must be chosen from task B. Okay, so let me tell you once again, if I amount of questions will be chosen from task A, then k minus I amount of questions must be chosen from task B. Then only the total number of questions that are being chosen is equal to k. Now at each step he is allowed to choose a task, that is choose one of the two arrays that has remaining unanswered questions. He is then allowed to answer either the first or last question. Now this is important. From the list of remaining questions of this task, once he answers this question, he gets the corresponding points and the answered question is removed from the task. Okay, can you help Charles choose the questions that will give him the maximum possible points? Okay, now the question is quite tricky. So let me just say that if I amount of questions is being taken from the task A and k minus I amount of questions is taken from the task B. Okay, so according to the problem statement, it seems that when you take a certain amount of questions from a particular task, what you will do is you will first look out for the set of unanswered questions. Now the set of unanswered questions is A0, A1 and it goes up to AN minus 1. Okay, now we need to choose uh, I amount of task. Let's say I is 3. For an example, let's say I is 3 and we need to choose 3 questions from task A, and this is the current set of unanswered questions. Okay, now how we are going to choose the questions, let me just tell you. So it says if you have a current set of unanswered questions, you can choose the questions either from the beginning or from the end. Like now you have to choose one question. You are going to either choose from A0 or you are going to choose an minus 1. Okay, suppose you have chosen A0. Okay, so A0 is chosen. It says that problem statement says that you are going to remove this A0 So current set of unanswered questions would become A0, A2, an minus 2 and an minus 1. Okay. Now the number of remaining questions that you have to choose is 2, because if I was 3 and we have chosen A0, now I will become 2. Now we need to choose 2 questions or more. So again we can choose either from A1 or either from an minus 1. Suppose we have chosen from an minus 1. So the new set of remaining questions would be A0, A2, and it goes up to an minus 2, because A0 and an minus 1 is taken. Now again I will become 1. So you need to choose one more question from this set. So you will choose an minus 2. You can also choose A1 also. Okay. So there are various possibilities how you are going to handle that. So let's generalize this case. Okay, so I need to choose I equal to 3 amount of questions from this task A. Okay, so let's say we are going to choose X amount of questions from front of this task A, and if I will choose X amount of questions from the front of this task A, then I minus X amount of questions will be automatically chosen from the back side of this task A. Okay, now why I'm doing like that? Because after I equal to 3 amount of operations, as I've said, like in the previous example, what I've done is I will extract it A0, an minus 1 and an minus 2. You can see the remaining elements are A1, A2, A3, and it goes up to an minus 2. Now you can see this, sorry, it goes up to an minus 3. You can see A0 is eradicated, A0 is eliminated, and an minus 2 and an minus 1, these both are like eliminated. So what is actually being done over here is we are basically removing some prefix and some suffix, such that the prefix length plus suffix length is exactly equal to I, where I is number of questions that is being removed from the task A. Okay, so we don't know this how much amount of this elements are being removed from the prefix side. We are unaware about that. So what I will do is let's fix out that X amount of elements are removed from the front side of the task A, like X amount of questions are being taken from the front amount, like from the front of this task A. Like let's say X is 1, so we will take only A0. If X is 2, we will pick out only 2 questions, A0 and A1. Okay, now if X amount of questions are taken from the front side of this task A, then I minus X amount will be automatically taken from the back side of this task A. Okay, so we need to find out we need to find out how we are going to maximize our possible points if we will choose I amounts of questions from task K and K minus I amounts from the task B. Okay, so now as I have said, I is going to vary from 0 to K. Okay, why I is going to vary from 0 to K? Let me tell you. Okay, now we are going to choose I, like I is going to vary from 0 to K. I is going to vary from 0 to K, both inclusive. We don't know how much amount of questions are being taken from task A, and we don't know how much amount of questions are being taken from the task B. Okay, so we need to maximize our answer by choosing K amount of questions in total. So what I will do is I will maximize our answer for every I in this range 0 to K. So what I will do is we need to maximize our answer for, let's say we have two linear arrays. For now, let us call it as dp1. Let me write down first and then I will explain you. dp1 of I plus dp2 of k minus I. For every I belongs to 0 to k, both inclusive. Now you guys must be thinking, what is this dp1 of I and dp2 of k minus I? Like what is this dp1 of I states that? What is the meaning of this dp1 of I? Okay, so let me just write down over here dp1 of I. So dp1 of I basically says that what is the maximum possible points you can get by choosing I amount of questions from task A. Okay, so let me write down the next page because it becomes quite gathered over here. So dp1 of I is maximum points we can get by choosing I number of questions. Okay, and what this dp2 of j will denote? dp2 of j will denote maximum points we can get by choosing j amount of questions from task B. J number of questions from task B. Now I'm going to iterate for every I in the range 0 to k because we don't know how much questions is being taken from task A and task B. We don't know. So why not we are going to check out for every possible values. Okay. So we are going to fix I in range 0 to k. Then we know k minus I amount of questions is going to be taken from task B. Okay. So if we know the values of dp1 of I as well as dp2 of dp2 of k minus I, let's generalize this as dp2 of j. If I will know the values that are present in dp1 array and dp2 array, then we can easily use this equation. Okay, so wait a minute, my pen is not working correctly. Okay, so if we know the values present in this dp1 array and dp2 of array, then we can easily use this equation and maximize our answer. Like maximum of all this will be our answer. So how do we know that? How do we fill out the values of this dp1 and this dp2? Now this is important. So if let me tell you, for the only one array you can calculate it for the another one. Okay, so let me check it out for the next page. As I've already said, let me choose out different color. As I've already said, we have this one a0 a2 and it goes up to an minus 2 and an minus 1. Okay, now as I've already said, we are going to fill out this dp1 value, dp1 of 0, dp1 of 1, and it goes up to dp1 of n minus 1. Okay, so dp of I, basically dp1 of I will be denoting maximum number of points you are going to get by choosing I amount of questions from this task A. Okay, so we don't know how much amount of task is being taken from the front, and we don't know how much amount of task is being taken from the back side of this. How much amount of questions will be taken from the back side of this task A. Okay, like from the back side of this array. So we are going to fix our x for in range 0 to I. So what I will do is I will write down our answer as dp1 of I will be max of what I will do is sum for the first x elements, let's denote it at sum 1, plus sum 2 for the suffix having size I minus x. Okay, now let me just explain this statement clearly because this is going to be important tricky point for this problem. So we need to calculate dp1 of I, which denotes maximum number of points you are going to get if we choose total I amount of questions from this task A. Okay, now we don't know how much amount of questions is being taken from the front. We don't know how much amount of questions is being taken from the back side of this task A, that is for this array. So why not we should fix the value of x, where x will denote the number of tasks. Let me write down number of questions taken from front. So if we will fix that, we know the total number of questions being taken is I. So if x is the number of questions taken from the front, so I minus x will be number of questions taken from the back. You can see x is over here and I minus x is over here. So dp1 of I will be max of sum 1 of x, which is sum of first x elements starting from a0, and the sum of last I minus x elements, that is from the suffix side. So dp of I will be max of sum 1 of x and sum 2 of I minus x. Note that x varies in range from 0 to 1. Okay, so if you are able to calculate this for every I in range from 0 to n minus 1, this dp1 of array is filled. Similarly, we are going to fill out this dp2 of array, and if you are able to do that, the remaining thing that we are going to do is again iterate I in the range from 0 to k, and we are going to maximize this value, which will be our answer. Okay, so one more thing I need to add up is what will be the time complexity or for this solution. Time complexity. So for filling dp1 of array and dp2 array, so for filling dp1 of array, time complexity will be O of n square, and for filling dp2 of array it will be m square, because for every I in range 0 to n minus 1, we are again iterating x in range 0 to I. So max size is n, so n square. Similarly for the dp2 of array, O of m square. And if you are able to do that, then again, like this was the pre-calculations that we are going to do, and again for I in range from 0 to k, just we are going to access this dp1 of I and dp2 of k minus I then linear time. So again our the remaining number of iteration will be k. So complexity will be n square plus m square plus k, which you can write it as in square complexity will be O of max of n comma m, you can say, and max of n comma m, let it be, let's say, some p value. So O of p square will be our complexity. Okay, so let's discuss how we are going to code that efficiently. Yeah, I think this is the code. So what I've done is, like, first I've taken the input for the array a, then I've taken the input for the array b, and here is the value of k. We are going to fill out this dp1 value and dp2 array and dp2 array respectively. Now before talking about dp1 and dp2, we need to understand that first we need to take out all the k questions in total. So we don't know how much questions we are going to take from the task a, and we don't know how much questions we are going to take from the task b. Okay, so let's fix that I amount of questions is going to be taken from task A. Then k minus I questions are going to be answered from the task B, obviously, because the total number of questions is k. So if I is less than or equal to n and k minus I is less than or equal to m, because if I amount of questions is going to be answered from the task A, then I must be less than or equal to n, because total number of questions present in the task A is n, and similarly total number of questions present in the task B is m. So if I is less than or equal to n, k minus I is less than or equal to m, then we are going to maximize our answer as max of answer comma dp1 of I and dp2 of k minus I. Okay, now dp1 of I and dp2 of I basically denotes that the maximum possible points you can get by choosing I amount of questions from the task A, and similarly maximum points you can get by choosing j amount of questions from the task B. Okay, so we are going to find out those linear array over here. So let's say dp is going to denote, as I've already said, maximum points you can get by choosing I amount of questions from the given array. Again, we don't know how much amount of questions taken from the front and taken from the back. Okay, now what I will do is, this is like this I will denote the total I elements are taken in total, and we have to take j elements from the front. So our current answer dp of I will be max of dp of I comma prefix of j, maximum j elements are taken from the front, and maximum I minus j elements are taken from the back side. Okay, that is from the suffix. So we are going to write down this statement. This statement basically finds out the last I minus j elements. Okay, so yeah, also we need to build up this prefix array and suffix array. Okay, and after all this is done, you need to just iterate it over here and just get the answer. So this is basically prefix suffix dynamic programming, prefix sum and suffix sum. If you are aware about that, you can solve this problem efficiently. So this is all about, guys, for this problem. If you guys have still any doubts, you can reach out to us through the comment section of the video. And thank you for watching this video, and do not forget to subscribe.